I'll apologise in advance because this is probably going to be a 20-minute disaster, but we'll try and see what happens. So before I start, just to thank you to Eleanor, wherever she's gone, for setting up the Cardiff Go group, and thank you to Alex and GDG for inviting us along. Just a little bit of a background. I'm Ian Kent. You can find me on Twitter or GitHub. I'm currently a technical lead at Office for National Statistics for the ONS website, and before that was a lead developer for the Company's House website. So, a very brief history of Go, and this is going to be incredibly brief. Go was started at Google in 2007. They've got an internal team that are dedicated to it, made up of Robert Greismer, Rob Pike and Ken Thompson, was the original team. About a year later, Ian Taylor and Russ Cox joined, and I think Alan mentioned earlier that a few more people have joined in the last few days. I haven't got their names. All the Gopher pictures, which I've massively overused throughout the entire talk, are by Renée French, so credit to her for the awesome artwork. Go was open sourced a couple of years later in 2009, and a few years after that, Go 1 was released in March 2012. Since then, there's been, I think, a couple of hundred separate external contributors, and I said it was going to be brief, so I've skipped quite a few years. Go 1.7, the most recent, was released in August 2016. There's actually Go 1.7.1 now, and I'm not sure when that came out. I probably should have checked. So the reason behind Go was built at Google to solve some of the problems they were facing. Things around being able to scale, not just in terms of performance and the technology, but in terms of the number of people working on the apps. It's designed to be highly concurrent and to have native support for networking and the web. So it's got built-in libraries for HTTP, JSON, and all of the other standard modern web technologies. So a very quick look at why we should use Go. I'm going to look at this from a perspective of a developer, because I think Alan is going to look at it from an organisational perspective. It's got a very simple language and syntax. The entire language is made up of literally just 25 keywords, which you can probably memorise in a couple of hours. It's got an excellent toolchain, which I'll demo some bits of in a minute. It's got built-in support for building Go apps, installing them as binaries, built-in support for testing and formatting your code, so all the arguments around spaces versus tabs and indentation doesn't matter anymore. It's strongly typed, which gives you the advantage over other languages like Perl, for example, that it catches a lot of basic errors at compile time. And I've got to drop this one, it's better than JavaScript. I'm only joking, a bit. It's also very fast and lightweight, so compared to other languages like Java, for example, where the JVM uses a couple of gigabytes of RAM just to sit there doing nothing, a Go app can use as little as 20 or 30 megabyte of RAM, and it's very efficient when it comes to how much CPU it consumes. There's no runtime. It compiles to native code, so it can make the most of the resources available on the machine. The other bit worth mentioning, it's got a very good community. So between the Gopher Slack channel and the Google groups, a lot of the community, including the core development team at Google, are very helpful when people have any problems. There's also a lot of great resources on the internet, which I'll give you a few links later. Makes it very easy for people to pick up and learn and get actively involved in the community. So, very quick look at the kind of things that are built with Go. There's a couple of names you might recognise. Docker is probably one of the best known ones. There's also Kubernetes, Prometheus, and Caddy, and another two, etcd and Terraform. That's just some of the best known names that I could find. There's a lot of others, so Gogs, which is the GitHub clone, is also written in Go. HashiCorp, that make Terraform, build most of their products in Go. And CoreOS, who make etcd, also build a lot of their products like Rocket and Fleet, all built in Go. So it's proven that it works at scale and works in very high volume compute environments. The bit that's probably more relevant if you're trying to convince people to use it, who else is using Go? Helps if I look at the right slides. So again, a couple of very big names. Google's a little bit of an obvious one. GDS, UK Government Digital Service, the front-end router component that all traffic that hits gov.uk all goes through a Go application. Also Medium and Facebook. I'm not saying that everything that they do is built in Go, but all of these companies have got at least a few components that a large volume of traffic goes through. Also Cloudflare and Netflix, and the same again. Netflix, for example, one of their apps handles billions of requests a day through a single Go app. And there's also a long list of others, so just to name a few, SpaceX and Uber both use Go. GitHub, the BBC, and maybe a bit dangerous to mention this one, but Yahoo. We'll ignore the recent news. So I'm going to do a quick 10-minute demo, and hopefully this won't turn into an epic disaster. So what are we going to build? So we're going to do what pretty much everybody's doing. Microservices, it's just standard these days. HTTP, there isn't anything else, is there? We just use microservices in that. JSON, everything's JSON these days. And importantly, TLS. I'm going to do this with nothing but the core library. There's a lot of third-party libraries that you can use that will help with some of this stuff, but all of this can be done with absolutely no external dependencies at all. So what are we going to build? Hello World seemed a bit boring, so I thought I'd make it really exciting and make it a Hello GDG app. It's going to be able to generate a hello something, so you can essentially pass in the name that you want. It is going to handle everything using JSON to demonstrate encoding and decoding. You can also pass it one name, or again, to make things really exciting, you can pass it multiple names and it'll return all of them. So this is where it probably really starts to go badly. I have to sit down for this bit. I did actually practice this a few times. We'll see how that goes. Live coding never goes well, does it? So.
Do the whole mic for you.
Yeah, if that's right.
Do you want to hold it?
You can try.
Just shake. Right, we got mics.
If I don't use a mic, can everyone hear me?
Yeah.
We'll try that. So before we start, a Go workspace is quite opinionated. You have something called Go path. That just points to somewhere on disk. Within that, you get 3 directories: bin, package, and source. Essentially, all of your source code goes into the source directory. Once it's been compiled, it goes into the package directory, and any binary applications that get created end up in the bin directory. That isn't really something that you can change. You just have to accept that's the way it is. There are cheats and workarounds, but generally it's quite a neat layout. Within the source directory, everything follows the way that imports work in Go. Use the actual version control path. So for example, on GitHub, you would have github.com/something/ the repo name, and the entire source tree is laid out in that style, which makes it very easy, if nothing else, to remember where you got the code from in the first place. So if I can remember how to use a computer. So as an example, you get that kind of layout. Can you actually see that with the sun shining on it? I don't think there's anything we can do about it, but I can try and avoid that bit of the screen if I need to.
A few times.
I might see if I can just avoid that bit of the screen for now. I'm going to try and get through this fairly quickly if I can. I hope we're getting this bit on video. So a Go application, pretty much you can name your files anything you want. They all end in .go. The most basic application you can write. This is where I make a complete mess of it. That is all that's required for a Go app. I mean, it won't do anything. If you run it, it does nothing. But that is as small as you can get an application. Make it a bit more interesting. So I'll cover some of this in a bit more detail in a minute. So that's actually a quick demo of one of the tools that you get, or as part of Atom at least, once you've installed some of the extra plugins. It handles import paths for you. So in Go, you have to be quite explicit in telling it what to import. You also, unlike a lot of other languages like Java, for example, you can't import something and not use it. So if you try to, it's a compiler error. The Go imports plugin essentially handles all of that for you. It doesn't always get it quite right, but it does a pretty good job. So if you run that again, it works. Go run essentially takes a Go file and runs it. If you've got more than one Go file, with the run command you have to name each of them separately. You can use Go build and Go install, which I'll come back to a little bit later. Go work out where I'm going next. I mentioned Go format that enforces the coding style. So if you try and do really nasty things like this, as soon as you save it, essentially in Atom, when it saves it, it's running Go format for me, but you can do that from the command line. It'll tidy it all up for you. As I said, it doesn't matter whether you choose to use spaces or tabs. As soon as Go format runs, it will clean it all up. A lot of open source projects, if you want to contribute to them, will expect you to run Go format on your code before you submit any pull requests. So we'll start off, because everyone's doing test-driven development. In Go, all of your test files are alongside the actual code. So unlike Java, for example, where you end up with a completely separate tree structure, everything is right next to the code that you're working with. So as part of this, the API that we're going to build essentially takes in one or more names and returns one or more hello something strings. So let's write a test for it first. Again, when you save it, it magically finds the packages that you need and imports them. The core testing package doesn't really have many helper functions. You're expected to essentially just use if statements, and you can call a fail method if it doesn't work. There's other libraries like GoConvey, which if I've got time I'll very briefly demo, that give you a lot of additional functionality around that to make testing a little bit easier. But this is just to prove that even within the core language, you don't necessarily need anything extra to have your tests. So we're going to have a generate function that you can pass 0 or more names in. I'll come to that in a minute. So what we want to say is, if the length of output is 0, no, it's already going wrong. If we pass in nothing, we want it to return nothing. So the first test is, if we pass in nothing and it doesn't, if it returns any more than that, then it's a failure. I was going to try and get clever and try and do this and then run the tests. I'm just going to write out all the tests first and then write the function that makes it work. So we also want to say, if we pass in one string, then we're going to expect one response. And if it's not, then it's a failure. And we also expect that the return value will say something like, I can't type, hello GDG, and that's also a failure. I completely forgot that I was supposed to be avoiding that bit of the screen. A slightly more complex example, so we'll say, and I've just realised the compile error. So in Go, part of the syntax when you're declaring variables, there's a few styles. You can literally just use the name and then colon equals. That declares a variable for the first time. After the first time you've declared it, you use just an equals. So ignoring the fact that generate doesn't work, that little bit there, if you can see that, the colon equals would be an error because that variable's already been defined. So let's fix that, and the same on that one. So same thing, if you pass in 3 values, then we would expect that the length of output to be 3. And let's just copy and paste that, because that's how we write code these days. I should be copying this off Stack Overflow or something, but know if you can see at the bottom, Go build has thrown a few errors, and that's basically saying that at the moment the generate function doesn't exist, which is right. I haven't written it yet. So let's write that. So for generate, we expect an input, and we're passing in a string. The 3 dots is essentially saying it's a variadic function. You can pass in 0 or any number of values. When you're inside the function, it's essentially treated as an array. The output, we're always going to return an array. In Go, you can choose to name your return values, and if you do that, you can just refer to them within that function by name. You can also not bother, and then you can just pass them in as a return value. But it reads a little bit nicer if you name them, and it also makes it easier to understand what the function is trying to do just from the signature. So for each name in input, so range essentially allows you to iterate over an array or a slice, which is similar but not quite the same thing, or you can use it to loop over a map. So for each of those, we want to really struggling to type and talk at the same time. So essentially we're saying for each name that's passed in, we want to create a string that's hello, whatever we passed in, add that to the array that gets returned, and return it. In a function that's got any kind of return value, you always have to use the return keyword somewhere. So even if, whether you name them or not, so let me explain that a bit better. I've named my return value output. I'm accessing it directly from the function. Because of that, Go allows me to just use the return keyword without passing anything in at the end. If I'd not named that, it would force me to actually explicitly say what variable I'm returning. So hopefully, as long as I haven't made a complete mess of that. There you go. So just using the built-in tools, that has run my test function and all of them have passed, just to prove that it really is testing something. If I change it to that and run it again, you get a failure. It isn't as clear as it could be on where the failure is, and I think my V flag may be in the wrong place. No, that is the right place. I was expecting it to tell me where. As I said, there are helper libraries like Go Convey and a few others that will make it far clearer where the test failures are. So now we've written our generate function. We've written some tests for it, and at the moment the app still doesn't do anything other than just prints hello GDG. So everyone's doing 12-factor, so the first thing we want to do is get some config from our environment. I'm not actually going to use it, but I'll include it to demo. So if you want to be able to set what the bind address is, so the port and hostname that it listens on, we can get that from an environment variable. And there you go. So another thing that Go is quite strict on, if you define a variable and then don't use it, that's also a compile error. It will force you, as a workaround, you can use an underscore, which basically is saying, I don't care about that value, and that'll get rid of it. Although now I've got a compile error because I'm not creating any variables. It's to help you catch fairly basic mistakes. So if you're refactoring a lot of code or writing a fairly complex function, it's going to tell you if you've forgotten to remove some code, or you're referring to variables that don't exist or that you've created and never used. So we'll also say if the bind address isn't set, because I'm not going to bother setting it, get my logic right, we'll set it to a default of any host name and port 8080. So the next bit we need to do, it's going to be a HTTP API, so we need some kind of routing and some kind of handler. So we'll start with the handler. The Go core library has got a lot of support for HTTP. So we're going to do it in roughly the style that you'll see throughout the Go docs. It uses a response writer for everything that you output back to the client, so status code or the setting head.request, which is the incoming request. The star at the beginning, if I can see that there, that's essentially saying that what we're expecting is a pointer rather than a value. The general rule in Go is while you're starting out, it's quite safe to use pointers pretty much everywhere. once you start to understand where you should and shouldn't use them, you can a lot of the time drop that. Essentially with the pointer you can change values. Without the pointer you've got a copy of the value and anything you change will be lost. So we've got a handler. We won't bother making it do anything quite yet. So the next thing we need to do is create a HTTP listener. So that'll actually open the port and listen on whatever port number we've given it. First I'll define the route that we're going to listen to. So again, using the core library, I hope I've got this right, we can essentially say listen or respond to any request that just comes in on /, and that's right in some. And that is going to be handled by our handler. Again, the support for routing is fairly basic in the core library, but it gives you the power to do all of this kind of stuff without any dependencies if you want to. There's something called Gorilla Pat and Gorilla Mux, which are much more advanced routing libraries. I'm skipping them purely for the point of not using any, but they add a lot more power and flexibility than you'd get just from the core. So the next bit we need to do is create the listener. I'm doing this from memory, so this could be interesting. So the first thing that you pass in is the bind address. We're doing TLS, so we're going to have assert and a key. And finally, the last argument is actually the handler that all requests will respond to. If you pass in nil, so in Go you don't have a null value, it's nil. I'm guessing that was just to be different, but it sounds nice. If you pass in nil, the HTTP library internally handles that stuff, which is how that bit works. That's registered essentially with a routing system within the Go library. If you passed in something there, so if you were using Gorilla Pat, for example, you'd have to pass in the Gorilla Pat router as part of that function call. Go is very explicit in error handling, so there's no exceptions, and you can ignore errors, but you really shouldn't. Functions can have multiple return values. Generally, the error value will be the last one. You should always check them if they're returned. The documentation for a lot of the core library tells you basically when you should trust the errors or not. So if you've got multiple return values, sometimes the first return value might actually be useful, even if an error is set. So you need to understand and read the Go doc to know how much you need to care about those. There are actually tools that you can get which fit into the Go toolchain, which will tell you if you're not handling any error values. So we're going to essentially say if error is not nil, then we'll throw a fatal error. Potentially I can demo that, so let's clear that actually. So the first error is we've told it we want to use TLS, but we haven't actually created any certificates. The core Go actually includes a helper script that will generate certificates for you. So I'm going to cheat and create those. So if I run that again, it's still output hello GDG, but now there should be a server listening. So if I curl localhost on port 8080, not particularly exciting, but it's given us a 200 response. So you can see that the server is there and is responding to requests. And so far, even if we ignore the generate and handler function that we're not actually using yet, we've essentially got a web server that works with the config coming from the environment in, what's that, 25 lines of code, with no external dependencies. That's entirely the core library. So let's make it a little bit more interesting. Actually, there is one more thing I'll show you. There's a particular syntax in Go where you can handle this if statement in line with that variable assignment. So in this case, we don't actually ever care about the error value unless it's set. So we can do, I think I've got the syntax right, just put the if at the beginning. At the end of the assignment, semicolon, error not equals nil. And we can get rid of that. And then Go can optimize that so it knows it doesn't actually have to keep hold of that value. It will just check it and throw it away if it's not needed. Not that at this point it really matters, but in other places, yeah, no worries. In other places that can be quite useful. So we've got the HTTP server, that's all working, so let's make the handler actually do something fairly useful. The the first thing we're going to do is we want to be able to pass in some name values. So we'll define an input struct, and on there you can either pass in a name. That bit is called a struct tag. It's slightly, it's not very strongly typed, so it doesn't feel like it fits particularly naturally with the rest of the Go language, but it does add a lot of flexibility around being able to mark up the actual data structures to say how you expect it to be encoded with XML or JSON or CSV. CSV might have been a lie there. So you can pass in one name or multiple names, and we'll handle those separately. While I'm here, we also want an output struct, so the input will be JSON, the output will also be JSON. So we'll say we've got a result, and the extra bit you can put in there is emit empty. So with JSON encoding, that's essentially saying if it hasn't got a value, don't include it. And we'll do the same with the results. I think I've got that bit right. So I'm going to go through this bit pretty quickly because I'm running out of time. So the first thing we need to do is read in the input that we were given from curl. So first of all, we'll read the entire request body into a byte array. If there's an error, then we will, I think that's right, we'll return a 400 response, because at that point we're assuming it's a client error, and just because we can, we'll return the error to the client. So again, we've got a compile time error that's essentially saying we haven't used B yet. So now we've got the request body in a byte array. We want to turn that into an input struct, and we can do that again with built-in JSON support. So JSON.unMarshal, I think that's the right way around, takes a byte array and a reference to a struct and will decode it for us. We'll do the same thing. If there's an error, then we're going to assume that that's a client error. And there you go, the compile time error is gone. The next thing we want to do, we'll throw another error if the user has essentially passed in nothing. And again, that's a client error. And depending on whether we've passed in one or many, we'll call the generate function. So missed a bit there. So we want to define the output struct, so that's what we're going to return to the client at the end. So if we've got just i.name, then we're saying we've passed in one name, so we'll put that into result. And we'll take the first response back. So the generate is always going to return an array, we'll just use the first value. Otherwise, we've been passed multiple, so we can say results equals generate i.names. And similar to the input with the 3 dots, we can put the 3 dots at the end of an array, and that will essentially unwind that into multiple values to be passed to that function. And because it's an array, we can just use the entire lot. So finally, we want to turn that back into JSON. So we've got the output struct, and this time we're going to use JSON Marshal. So I think I've got that right. JSON.Marshal and pass in the output struct. This time, so we'll still return an error, but this time if it doesn't work, it's a 500. If something's gone wrong with encoding that value, we'll send that back to the client. There's not many reasons that should actually ever happen. So if we get to this point, everything should have worked absolutely fine, hopefully. So we'll write a 200 response. If you don't set one by default, it'll get a 200 response, but you can, it's clearer if it's set and you know that it's actually that and nothing else has changed it anyway. We also want to set a content type header so we know that it's JSON. And finally, we'll write the response to the client. And if I haven't made a complete mess of that, that's 85 lines of code, and we should hopefully have a working API. Trying to remember how to do this. So if we pass nothing in, we get the error from the JSON decoding. If we pass in an empty JSON document, then we get the error that we set. If we pass in one name, you get a result which is hello GDG. And if you decide to pass in multiple names, and it works. And I think I'll give up at that point. And there you go, a working API in about 10 minutes. If anyone's interested in learning a bit more, there's some useful resources. There's a couple of others that are probably worth mentioning quickly before I get kicked off. There's Awesome Go, which is a very long list of Go examples. And there's also the Go wiki on GitHub, which has got loads of other resources and examples of other companies that are using Go. Thank you.